Delighted to be with you. My name is Lloyd Taylor. I have been doing internet engineering for well over 40 years. Got started in DARPANet as part of my work at Johns Hopkins back in the early 1980s. That doesn't make me special. It just makes me very experienced with things not working right. One of the things that I've worked on throughout my career is models for making decisions about software, about hardware and infrastructure. As Thomas said, I cut my teeth at Hopkins. I worked up through Digex, one of the early managed hosting businesses. I was an early employee at LinkedIn. I was responsible for all the global data center expansion for Google. And also, as he said, trying to drag Autodesk from a desktop company into a cloud company. So what I'm going to present today is a model that I've built over the years to try to guide decision-making about software development. Next slide, please. We're going to go over several things. Sort of what are my options? And obviously there's several. We're going to go over the model of domain-driven design, which I find very effective for making decisions. And then a decision matrix, which is based on thinking about opportunity cost, specifically opportunity cost for software development and operations. Next slide, please. So how can we build applications in the cloud? Well, obviously custom code. Everybody likes writing custom code. It feels good. It's great to have full control over what you build, but you can't build everything. And so the second choice is third-party code, things like commercial code or open source. And then the final option is software as a service. By my definition, custom and third-party code is something you host yourself, where SaaS is always hosted by a SaaS provider. Next slide, please. So custom code, two really important questions to ask when deciding if you want to do something custom. Recognize that every line of code is a liability. It costs money to maintain. It costs money to build. There's an old joke that every time you ship a new feature, plan on cutting your engineering team in half because the other half's going to have to support the feature that was just shifted. So the key thing, though, is what the code does for you as an asset. So the first question to ask in trying to decide if to do custom code is, does the expected financial return for your company from the custom code justify the cost to build and maintain? Look at the cost of development and operations versus the revenue you make from it. It's a really interesting way of thinking about the code. Next slide, please. For commercial code, things like Oracle or any of the other packages that you buy and run locally, obviously, we have to think about the purchase price and the maintenance cost. What are they going to charge you each month? Another thing to really pay attention to is what are they going to charge you to support the software? These can be very, very big numbers. It's not uncommon for enterprise to be spending $10 or $20 million a year to Oracle for both the purchase and maintenance and for the maintenance support. The thing that a lot of people don't think about is there are still in-house staff requirements for commercial software. Someone has to be trained on how to run it. We have to maintain the vendor relationship, contract negotiations, release tracking. Every time the vendor comes out with a new release, that has to be factored into what we're building. And the other thing that people often don't think about is every time there's a release in the commercial code, there's a high probability that we're going to have to refactor some of our in-house code to adapt to that. Next slide, please. Open source. Open source is great. Lots of rich selection of functions and tools. Picking heavily used and well-supported OSS can actually give you code that's much higher quality than commercial code, plus it's open, so you can go in and see what's going on. One of the things to pay a very careful attention to is license terms. One of the things my attorneys advise me is never use GPL3 license code unless you have really good attorneys. So try to pick licenses that are more open, like the Apache license or so forth. The other thing that's really important in OSS is keeping track of the CVEs and the security issues. Every time I go into a new company or I'm consulting with a company, we'll often go in and look at what is the release versions of their open source packages that are in production. And it's super common to find that these things have not been updated in a year or two and have dozens of known CVEs against them. So as you're thinking about open source, do pay attention to the cost of maintenance and keeping up with the releases. Next slide, please. Finally, software as a service. The whole point here is you're outsourcing the functionality. Picking best-of-breed providers like Ory, like AWS, deliver very high quality, well-maintained, secure services. The thing that I always do is I look for SaaS providers whose corporate reputation is on the line. If I'm going to pick a security vendor, I need to make sure that should they screw up security, they'll go out of business. So making sure that they have skin in the game and that their reputation based on the quality of their software is very important in picking a vendor. Another thing to just watch out in SaaS companies is they can change pricing on you. So make sure you've got good contracts, make sure you understand tiering. A lot of companies will actually have what's called ratchet pricing, is when you go above a certain count, your price goes up. And if you drop below that usage, the price does not go down. So Akamai, for example, is quite famous for doing this kind of pricing. One of the things I've also learned very painfully is a great way to determine the quality of the SaaS provider is the quality of their documentation. So super high quality documentations from a company like Stripe and really good sandboxes to test your API integration with are a really good indication that you're working with a high quality company. Thank you. Next slide, please. All right, so that's the four kind of pieces that we can pick, our Tinker Toys or our Lego blocks for building our application. The second kind of question is which kind of blocks and which kind of building parts do we want to use for different kinds of code? I find the model of domain-driven design very effective in thinking through this thing. What domain-driven design talks about is there's three subdomains in developing software. One is core. Core software is what makes your product special and what makes you money. Supporting software is software you need to support the core functionality, but isn't making you money. And then finally, generic is needed, but not specific to your product. So as we explore what kind of software should we write or should we buy, which should we use from third parties, let's keep in mind the problems we're trying to solve. Next slide, please. So if we boil this down, this is not the deck I uploaded, but okay, I can work with it. What we can look at here is on the left, on the y-axis, we're looking at the complexity of what we're trying to solve. And on the x-axis is the business differentiation. What this model says is for things which are high differentiators for your company and high complexity, those should be considered core code. For things which are lower differentiators, but a wide varieties of complexities, that's where we consider it supporting code. And if the differentiation is low, and frankly, security and authentication is a low differentiation product, we almost always want to be considering that generic. Okay, so that's just the model we're going to work with. Next slide, please. So again, definitional. Core is software that directly makes money for your company. If it's not making money for your company, it's not core software. Now that's contrary to what a lot of people think. And part of it is I want to be able to control my own destiny. On the other hand, if we're going to be focusing on things which are profitable and help us grow in the market, we really want our developers focusing on the things that make a difference to our customers. Where there are unique features or functions, custom code makes a ton of sense. The thing I see over and over in the companies that I either invest in, advise, or help build is that there's a consistent problem that engineering resources, sometimes we call sustaining engineering, are not explicitly allocated to the ongoing code maintenance. If you do not make the effort to assign people to continue to work on the code, tech debt will destroy the product over time. The other thing that we have to be very careful about is our build and CI systems must have absolutely aggressive security scanning and testing. The thing about commercial software or open source software is there's often many people using it. There are outside review. There are good security practices. For code we build ourselves, we don't have that opportunity. So not only do we need to have very strong coding guidelines and security requirements, we have to have very aggressive scanning, fuzz testing, lint testing, those kinds of things, threat surface analysis. So if you're building your own code and you don't have really strong CI build system doing the security testing, you're also looking for trouble down the road. Next slide, please. For supporting software, we're talking about it's software that enables your core software to function well. So some examples, commercial would be things like buying a database, Oracle, CockroachDB, Postgres. Third-party code can serve very well here, both open source and commercial. The commercial code costs more, but generally is, somebody else is responsible for the day-to-day maintenance. OSS costs less up front, but cost for maintenance is problematic. Again, if you're not building and maintaining, if you're not maintaining your own code, who's in charge in your company of making sure that your OSS versions are current? And then, there's certainly managed services here, which are partly third-party and partly OS and partly commercial, partly SaaS. Things like RDS or Aurora or Bigtable are managed instances of commercial software. And again, if you're doing supporting software, whether it's third-party or commercial or open source, again, you have to assign engineering resources to maintain the supporting code and maintaining the patches, the upgrades of either the OSS or the commercial packages, and work with your own developers on having to update your API calls or your software interfaces, your monitoring code. All of those things have to be paid attention to. What I've also found over time is if I'm going to be using certain OSS packages or certain commercial packages, having really strong both technical but business, legal, and financial relationships with whoever owns the code or whoever's working on the code can be very helpful when it's time to resolve a problem. Thank you. Next slide, please. And then finally, generic software, which is common across multiple functions. These might be things like an operating system, like a CI/CD standard, authentication, security. These are all things which are pretty much the same for every application in the cloud. And those are ones that really we should not be spending time building ourselves because it gives us no strategic or tactical advantage. SaaS is great for generic functions. And SaaS provider handles all the patching, updating, and securing. The main issue is making sure that they're good at versioning APIs, that they have good API documentation, they have good sandboxes, so you can do all the testing you need against the SaaS product without putting your own product at risk. And again, as I said before, I'm very particular to special purpose SaaS companies whose survival depends on delivering high quality, secure systems that I depend on. Making sure they're aligned is great. All right. So the final model I'm going to introduce is the idea of opportunity cost. This is a thing you see a lot in finance. I think it makes a ton of sense to apply it to software development as well. So opportunity cost is defined as the foregone benefit that would have been derived from an option not chosen. So let's say, for example, you choose to build your own authentication system in-house. Not only are you it may seem like good sense, but what's the opportunity cost? How many developers have you taken off your main product, the ones that make you money, and apply it to things which are not making you money? So that's a key thought. And so what we have to do is we have to evaluate opportunity costs, we have to look at all the options and weigh them against each other. Next slide, please. So if you think about what are the opportunity costs for software, very specifically, this is a model I found very useful. There's how long does it take to build? How much software engineering, how much and so forth, things like that. Customization, how much time do you have to spend on customizing if you're doing OSS or third party for what you're doing? Maintenance for software is always underestimated. And it's something that's really expensive and is often not done, which leads to outages, which leads to problems with the software. Scalability. On the cloud, scalability is hard. The cloud is a shared nothing infrastructure, and therefore scalability can really bite you in the bottom. Costs, we look at both soft costs and hard cost. A soft cost is a resource you have. So a developer is a soft cost. You'll be paying the developer regardless of what the developer is working on. Hard costs are costs of money that leaves the building, money for a contract. So buying commercial software is a hard cost. Developing software yourself is a soft cost. Security gets harder and harder as the days go by. There was just a huge release of a whole bunch of Russian data today, 1.2 terabytes of hacked data. It's hard to maintain that. If city-states themselves, like Russia, are having trouble maintaining security, how is it that we're going to do it? And then the final stage is customer support. So what I've done is I've taken all of these ideas and put them together into a single framework for making decisions. Next slide, please. So what we're doing here is we're looking at the opportunity cost components down on the y-axis, and we're looking at the type of software selected on the top. So at the top from left to right, we have custom, commercial, OSS, and SaaS. And as you think, this is the model. These are the values I generally see in doing this work, but you should go through each of your own decisions and decide, what is the opportunity cost? So build time for custom is very high. It takes time to build, to develop and build that software. If you acquire the software, it's very low because you've paid money for the build. For OSS, you have to integrate it and build it into your system, so it's medium. And SaaS is low because somebody else is handling the build for you. So I won't go through every one of these models. I'm happy to take questions about this or talk with you privately if you'd like. But ultimately, going through and thinking what costs you're going to avoid and what costs you're going to have to swallow for each of your choices can help you guide very specifically as to where's the best investment of your developer time. Next slide, please. So in summary, if you look at all these numbers, and I realize we've just gone through an entire semester in about 20 minutes, for core, almost always custom code or very carefully selected OSS modules. Those are the things that you're using to deliver value to your customers. For supporting software, almost never custom code. Commercial code, OSS, or SaaS all makes sense. And for generic code in today's world, there's absolutely no reason not to use SaaS. It's not anything that makes a financial difference to your company. It can be very, very hard to do it well. And finding someone whose company survival depends on the quality of the service they're providing ensures that your intent and the company's value are aligned. So you have a very high probability of having a successful product and actually focusing all of your engineering resources on the things that make a difference to your company. Next slide, please. So, oops, we didn't get that. All right, that's fine. So finally, let's just open it up for questions if you like. I realize this is a very fast talk, but I think it's a very useful model for you to look at. Feel free to use it, not use it, disagree with me, happy to chat about it. But I think that if we go back one slide, if one is very careful and in a disciplined way goes through each of the software systems, should I do it custom? Should I do it commercial? Should I do it OSS? Should I do SaaS? And be honest with yourself about not only what it's going to cost to do it this way, but what opportunity cost is there for not having, say, 5 engineers focusing on some generic component, not working on the part of the code that actually makes you money. With that, I will stop and open the floor for questions.
Any questions for Lloyd about this very interesting experience view on building applications? I have one there. Tobias has a question. And then
Thank you, Lloyd. That has been very helpful.
one second, Tobias, we're getting the microphone to you there. Then after that, Kevin has a question, so you can.
Thank you, Lloyd. That has been very helpful. Could you elaborate a little bit where we would be in 3 to 5 years? How all of that would look like for the SaaS business?
I don't think this model changes much. What happens is more and more of the common or supporting functions are going to be available through software as a service. I have a startup right now, and I'm using a lot of what I call bureaucracy as a service company. So companies like Deal to hire people remotely. And what they're doing is they're solving a generic problem for me and just charging me a fee to do it. So my company only operates in the United States, but we hire people all around the world. And by using a company like Deal to handle hiring, the local benefits, and so forth, I don't have to worry about that. So what I see happening is over time, more and more of the common services are done in SaaS. That means that our development is just much more focused on building code that actually makes us money.
Kevin has a question. Go ahead.
Hi, Lloyd. Thanks for this great talk. Question, when it comes to core functionality, What are your thoughts around building that as proprietary code versus as open source code itself?
I think there's a technical and a business. So generally, core code is going to be the code that makes your company successful, that you can sell. I think components of that can certainly be open source, but it's like, Google is never going to open source their ranking algorithm because that's what makes them money. So I think in general, one wants to try to write open source if there's useful functions. But on the other hand, if sharing that source puts you out of business, you've just shot yourself in the foot for being able to develop more open source code. Does that make sense?
Yeah, thanks.
Any further questions for Lloyd? If not, I have one, and it's more of just also an outlook, Lloyd. What we've seen in the past sort of 5 years is that there's a larger scale industrialization going on around open source. And in particular, let's just take Kubernetes as an example, where Google spent quite a lot of money building something and then made it open source successfully so that the broader industry could benefit from that. How does that affect your decision and your opportunity costs? I mean, when you have a company like Google behind an open source project, is that something that you would say, Google's reputation does not depend on Kubernetes, but the industry depends on Google to make the changes and the necessary investment required to drive the future of Kubernetes. Is that something that would change your opportunity cost calculation?
I think when companies like Google open source software, it's generally because they've decided it's to the benefit of Google to do so. That might be reputation, that might be, well, if everybody does Kubernetes, it's easier to sell GCP. So one always has to watch out for the profit motive for software which is offered and run by commercial companies. That's why stuff when it moves to the Apache Foundation, to me, is much more sensible. You have a nonprofit foundation which was responsible for it, companies can contribute to it, and so forth. One of the things I learned when I was working at Google is Google solutions are designed for Google. And very few people run things at the scale of Google, or AWS, or Azure. So while it can be a lot of fun to say I'm adopting a tool set that Google developed, if one is running 500 instances, one really has to question whether Kubernetes makes sense. Because there's a ton of complexity. Think about the opportunity cost of all the people who are building and running your Kubernetes systems. I think that's the key thing I see over and over again in decisions that companies make, is they just do not consider the opportunity cost. That's not just in software, that's in all business decisions. Did I get to your answer, Thomas? That's a very complicated question, actually.
Yeah, no, I think it's interesting because it affects the way you look at using some of the open source software, but it also, again, I would say challenges the assumption that if you choose open source, is that the lifeblood of the company? And I think in some sense what we're seeing is a lot of bigger projects, VS Code, React, a lot of bigger projects coming out of large companies that are to the benefit of those companies for sure, but also have had a very broad impact on the overall software industry because of their financial backing and because of the amount of developer time and effort that they put into that. I think that's just again, one more wrinkle in the equation. How do you evaluate a vendor's commitment to open source? Ory depends on open source. That's our lifeblood. We live or die by the value and the quality of the work we create. We see a lot of those companies, though, that don't do that and still have a big impact in the open source industry. So the question was more about how do you see that evolving? How do open source companies like Ory compete in that world where you have major financial backing for businesses and open source projects that do not depend on the broader community for active development?
Agreed, and there's another talk I can do, which I won't do today, but it's about what are the business models that work for open source companies? How do you monetize open source? Right. Because there's a lot of models and most of them don't work. Yeah. So that's really kind of an interesting discussion itself. I mean, look at what's been going on with CockroachDB and them trying to figure out how to keep the company going when people can just replicate their code and offer it as SaaS. They're trying to restrict that use. So just have to think about that in advance.